So we're going to simulate another one, 1024.1 and minus 0.25. I got that using this. Is that 0.1 or
Wouldn't it be 1?
it has to be 1? Still worked in a grey. Good. So negative 0.5, negative 0.5, that would be 1. Followed by 0.25, that's quiet. So that is our true model, and I have the ACF and the ACF. So that's what the ACF plot looks like. Interesting. Yes, and that is our series. It's not noise, it's definitely correlated in our series. We're good. So definitely oversight on my part. I overlooked this. What were the rates? 1.25. So plus or minus 1.25. Even though they are the same in magnitude, still they are distinct roots. So we'll go to another true model.
Oh wait, that model is that.
Alex. It's not Alex. So yt is equal to yt minus 1 minus 0.25 yt minus 2 plus epsilon t, where epsilon t is our standard noise. Yes. So yt minus 1 minus 0.25 yt minus 2. Which would mean if we move the terms to the left hand side, yt minus yt minus 1 plus 0.25 yt minus 2 equals epsilon t. Yt, L times yt, I'm pulling yt out, so L plus 0.25 L squared equals epsilon t, which would mean Fieldsland will be 1 minus z plus 0.5 z squared. Let's find the roots. Fingers crossed. Definitely outside the unit circle. How about that? So the roots are repeating. Both of them are 2. So that would imply lambda 1, lambda 2. Both of them are 1/2, which would give us 0.5. Yes. Now we know how to find C1, C2. What is C1? Lambda 1 divided by lambda 1 minus lambda 2. Which will cause a problem because we'll have 0.5 divided by 0.5 minus 0.5. And that is not going to work, right? You would end up having undefined. The same is going to happen with C2 also, correct? So what do? We actually go for the psi j expression. And we can have C1 lambda 1 raised j. But I can't simply put plus C2 lambda 2 raised j, correct? That wouldn't make any sense. So C2 j multiplied by lambda 2 raised j. Good. So if I plug in 0 for j, I will simply get C1 lambda 1 raised 0 plus C2 0 lambda 2 raised 0. So we will get C1 equals psi naught. Yes? If I plug in j equals 1, I'll have C1 lambda 1 raised j plus C2 lambda 2 raised j. J is 1. So we simply have C1 lambda 1 plus C2 lambda 2. We know that C1 is 1 because psi naught is always 1. So this would equal to 0.5 plus C2 times 0.5. And that would equal to psi 1.
So we could,
And that is going to hold true for some constant C2. When we move on to psi 2, we'll have 0.5, C1, C2, J, and you simply use the recursion again. You have expressions in terms of C2. And you may ask, well, how do we find C2? In differential equations, you have a bunch of constants. How do we find the constants that we do not know? What do we need? Oh, you took differential equations.
yeah,
You took differential
like
equations.
4 years ago.
But so if you have, we always have constants in the solution to a differential equation, right? How do we find those constants?
Well, we need to get integral of its constants.
Right, how do we find those constants?
The integral. Constants are us.
There is a thing called initial conditions and boundary conditions, right? So we've got to use some sort of initial condition to come up with values constant C2. Another way is to divide by that term on this side, which would give us 1 over 1 minus L plus 0.25 L squared. We can use long division to find psi 2. What do I mean by that? Excuse me, psi 1 do we know long division? So if I move phi z to the other side, yt would be 1 over phi z multiplied by epsilon t. Numerator is 1, and we are going to divide it by 1 minus z plus 0.25 z squared. Yes? which if I rewrite it in decreasing order, it would simply be 0.25 z squared minus z plus 1, right? And in this case, we are going to try and get rid of terms past our standard long division. What do I mean by that? I could put 1 there, then I'll get 1 times 1, 1. 1 times minus z, minus z. 1 times 0.25 z squared. Yes?
8.25.
Oh, thank you. 0.25 z squared. Subtract. Go forward again. Z minus 0.25 z squared. We need to get z here so I can cancel it out. So plus z. Lovely. So we will end up getting z minus z squared minus 0.25 z cubed. So this is going beyond the standard long division that we would do. In the sense, in typical long division, we would stop if the dividends degree is less than the divisor. But here we'll keep on going. So those two would go away. And if you subtract that, what do we get? 1 minus 0.25 is 0.75 z squared plus 0.25 z cubed. And it can keep on going. I'm going to stop right there.
It gives me the cube, we're only in AR2.
Then AR2, keep in mind, it can keep on going. It's only MA where we stop in order Q. Well, so I do this, I end up getting sine 1. I got sine 1. Yes? So I have sine 1 to the big 1. So if I divide by 0.5, I get 2 equals 1 plus C2. Which would mean C2 is also 1. Good.
What did you divide by?
0.5. So I've got C1, I've got C2. Of course, you can find C2 using some initial condition, but I'm doing this approach. So going back to our psi j, we know C1, we know C2. So psi j would now be equal to 1 multiplied by 0.5 raised j plus C2 is also 1.5 raised j. Correct. Which is 0.5 raised j times 1 plus j.
So how did we, why did we do the long division?
To find C2. Psi 1 is equal to 0.5 times 1 plus C2. We did not know C2, so I did long division to find C2 using psi 1. You may say, could I not proceed with long division forever to get the coefficients? Sure, if you want to, keep doing that. But we're trying to be effective, right? So I can stop right here and get the values of C1 and C2. Use that to find psi j. So let's see. If I plug in 1, I have 1. Yes. And 1 plus 1, 2. So 0.5 times 2 would be 1. Psi 1 was 1. Well, now I can find psi 2, psi 3, psi 4, and so on.
I'm sure psi 1 was
Psi 0, psi 1.
Is it just a coincidence that the same, like the psi one is also what equals for the long division? Yeah.
They should match up.
Okay. So
Yeah, they have to match up.
Alright, so.
Right.
you could just-
So they have to match up. So
Will the constants always be the same? For.
no, the constants could be different. Yeah, we just got
one.
like.
But psi 0 and psi,
Okay.
psi 0 and psi 1 should always be the same.
That's what I was doing for loop. Was they equal to?
Yeah, not necessarily. In this case, we got lucky. What is psi 2? If I plug in psi j equals 2, I have 0.5 raised 2 times 1 plus 2.
Wait, Professor, so psi 0 and psi 1 will always be the same.
No. Psi naught would be 1. Psi 1 could be anything. In this case, we got lucky. It ended up being 1. Psi 2 is 0.75, yes. So if you proceeded with long division, we have 0.75 here, right? So I have to multiply by 0.75 z squared to get rid of this and move on, correct? The point of that is that, okay, we find the 2 and we can generalize it, psi j, and all I have to do now is plug in values for j and we're done. Does it make sense? You can take this approach to find the values of psi, but do you want to work hard or do you want to work smart? Smart. Smart approach. Nick?
Does that mean psi 3 would be 0.25? So I was just trying.
How about this? Go ahead and divide. One more step, I'm running out of space. So go ahead and divide, get rid of 0.5 z squared and tell me what z cube will be. Does that cube tell? So the next term should be 0.5 or 75 z squared. Yes. So 0.75 z squared plus 0.25 z cubed, 0.75 z squared, 0.75 z squared minus z minus 0.75 z cubed. Yes. And 0.75 z squared times 0.25, 3 over 16, 0.375. You guys have the calculator. 3 over 16.
Exactly, because it's 0.25.
0.0125.
3/16.
0.1875.
There we go. Okay, it's cheap. 0.1875. Z raised 4. Subtract. Those two would go away. 0.25 z cubed minus 0.75 z cubed, I'll have z cubed, plus 0.1875 z raised 4.
What do you mean 0.5 say cubes? Or negative 0.5?
That's what.
Negative.
No, we. 0.25 minus 0.75.
Minus. I'm subtracting the 2.
Okay.
Right, let's plug in psi j equals 3 and let's see what we get. So 0.5 cubed times 4.
0.5. I got 0.5 for that.
0.5? Yeah. That has to be 0.5.
It is 0.5.
This is 0.5.
Because if you do 0.25 minus,
Minus the minus. Why did I mess with the sign somewhere? So minus,
I think you did.
huh?
I think you
I think I messed with the sign somewhere. So that's,
Because it's minus, instead of squared, it would be negative, it's your bottom, it should be negative up on
this one.
top. Yeah.
Yeah. So that's negative. That has to be negative. That would become positive.
And that top one, yeah.
Yeah, that would be 0.5 exactly. Right? So now side 3 would be 0.5. So you can see that doing long division is going to be painful. But knowing the side weights is good. We want the side weights. So that we can easily find them once we evaluate the constant C1 and C2. If this happens to be an AR3 model, then we want C1, C2, C3. So we have to go one more step in long division to find it. Of course, there are other ways to find the side weights, but one of them, right? So we know side 1, we know side 0, we found side 2, side 3, and we can keep on finding all sides using that. Good. Estimating phi1 and phi2.
Most of the few filled that open, but I think that
Okay. So the evaluated values of autocorrelation are 0.803 and rho 2 is 0.560. Right? That's what we get from the sample autocorrelation. So those are the estimates. How do we find the value of phi1 and phi2 if we have estimates for rho 1 and rho 2? We'll use the Newell-Walker method to find the value of phi1 and phi2. If you recall, rho 1, rho 2 would equal to 1, rho 1, rho 1, 1. phi1, phi2. Yes. Just plug in the values, 0.803, 0.560 equals 1.803. phi1, phi2. And we can find the value of phi by doing phi inverse A. You have the calculator, so give it a try and tell me what the coefficients are. I'm still not sold on this one. I'm just challenged.
It's still not sold on your division.
Yeah. Something bothers me.
the whole thing published.
It's really just long division in general. She's
I'm still trying to figure out those the whole part.
I hate
Yeah, like the whole C1.
it's different with real numbers, but when you start adding variables, it's very,
Aha.
tells you variables. Figure it out. It's your plus, that's what I was told.
Yeah. Cool. Now,
Almost like that.
yeah.
Cause I had it minus knowledge already.
Now I get that. You see, I knew something was off.
And you're
So-
just erasing something else.
So, yeah, we get 0.75. The reason why I thought something was off was, sure, we got 0.5, but then we had negative 0.75. That doesn't make any sense because side 2 is 0.75. So it was bugging me, so I wanted to finish this and now I messed up in non-division. So the next one would be 0.75, that's why. And that would give us 0.75, that's why minus 0.5, z cubed, and this would be
There you go,
minus,
there you go.
and life is good now. You corrected me, but
I did, we just didn't fix it.
I just didn't. Well, I'm sorry.
It's okay, it doesn't hurt my feelings.
That's